Hi, my name is Baishun, and today we'll be talking about object-oriented programming. So, so what is object-oriented programming? Well, basically, object-oriented programming is when you use classes to create different objects and then they interact with each other. So, like, for example, there could be like if you wanted to like have a bank account, you could have a dog class, I mean a banker class and a money class and a like accountant class, and all these classes would interact with each other and it becomes much more organized. And then in object-oriented programming, you will have, for example, you can have class variables, and these things are available throughout the entire um these variables are available for every single different instance of an object. So for example, if you wanted a class variable like for example count, you can keep track of how many different objects of this class that you've created. So for example, you could keep track of how many customers you have. And then there's also data members that can be associated with each class. And then there's function overloading. And what function overloading is you can have a function that is assigned to an upper class. And then this upper class, you can have many classes inside of it that do different things. So for example, for function overloading, you could have an animal class that makes sounds. And then, for example, you could have a make sound function. But then in the make sound function, you could have different animals. For example, you could have a cat class that is inherited from the animal class and a dog class. And then because you have these classes, they make different sounds, but you still want an overall make sound function. But then within the cat class, you'll overload the make sound functions with like meow, for example, that the cat class will do meow and the dog class will do like woof, right? And then there's also instance variables. And instance variables are just variables that are defined for a specific object. So going back to the animal analogy, for example, if you had the dog class, each dog could have a different age. So what this would be was an age variable would be an instance variable, right? Because this isn't shared across every dog. A dog could be 2 years old or 5 years old. And then next, we also have inheritance. And what inheritance is what we kind of did similarly to before, where um, inheritance is when a class takes function, like inherits from another class and takes functions from that class, and then it uses that function, those functions, and it can also add its own functions. So, for example, going back to the animal analogy, we can have a cat class that inherits from an animal class. And then there's also instances, which are basically the objects. Like, for example, for a dog class, you could have, for example, a dog called Buddy, and Buddy is an instance of the dog class. And then instantiation is when you make these instances from the class. And then we have methods, and methods are different functions basically that the classes or the objects can perform. And then we have objects, which are similar to instances. And then we also have operator overloading, which is on the assignment of more than one function to a particular operator. Okay, so then first let's go over inheritance. So basically what inheritance is again is that it's just inheriting from another class. So basically you could have class. This is basically what inheritance does. And then we can do, so this is just the basic syntax for inheritance. So you have a new class and this is the name of the class and then you put the parent class in brackets between that part so then you can which shows which classes you're inheriting from. So for an example, you can have class parent and how you do this is you define a parent class and then um you have you can have parent and then and what this function is it's the constructor function, which basically means when you make a new parent object, it will immediately call this function. And then you can also put methods in the parent. So for example, it's just a method that you could have. So, and then you can also do, if you want to set an attribute for yourself, you could also do what this function does is it takes in the parameters of attribute. So you can set and give this function an attribute, and then the parent attribute will be turned into this variable. So that's another function you could do, and also you can do a get attribute function. So, and then here's the interesting part where we can also define a child class that inherits from the parent class, and we can also do many interesting things now that we are inheriting a class. So for example, and here we can see this is the class name like we showed here, and then this is the parent class name inside the parentheses. So then what we write here is we have to add another constructor function. But now that we have this function, we already have a constructor in the beginning in the parent class, so then we can just also use that. So how do we call that? We have to use the super function. So super dot. And what this does is this calls the parent function. So when you want to call a parent function, you use the super function. And then, yeah. And then you can also add another method. So we can have this is an extra method. So for example, And to show how this works, we can define some objects. So this is where um, um, objects come in, or instances. We're defining a new instance. So all we have to do is C equals child. Yeah, child method. That's calling it. And we can also call the parent method. And even though the parent method is not specifically within child, because child inherited from parent, and it's basically another parent class, we can also call parent method. So basically think of when you inherit from another class, it's the class that it inherited from and all the attributes that it has in its own class. And then you can also do, and we can call these functions again because child is inherited from parent. So now when we run this, we can see. Here we see, so first, this part comes from when we printed this, we called the super part. So then it printed calling parent constructor. And then it also printed calling child constructor because we added that right under. And then here, this is calling child method is printed because we just called this. And no extra parent or anything is added because within this child method, we don't call upon any parent method. But then when we call parent method, it can call parent method. And then when we set attribute, it'll change the attribute. And then we can also get the attribute. And that's why this is printed. So now that you know a bit about what inheritance is, let's define it more distinctly. So, what is inheritance? Inheritance is the mechanism in object-oriented programming that allows the child class to inherit attributes and methods from the parent class. So we saw that with this parent and child, right? We were able to add our own methods with like child method. We were also able to inherit the methods from the parent class. For example, we could use parent method and set attribute, which were not clearly defined in child class, but instead in parent class. And then why should we use inheritance? It encourages code usability and establishes a hierarchical relationship between classes. And what this means basically is, again, going back to the animal class idea, because some classes are very similar and they have very similar reactions, but they're not exactly the same. And this is where inheritance comes in hand because we want to keep some actions the same, but we don't want to have to rewrite them over and over again. So then we can use inheritance. And it also is useful to basically the hierarchical relationship, it gets more and more specific, right? So for example, we can have a car class, but then under the car class, we can have like a Honda class. And then under the Honda class, we could have the Honda Civic class. And then with each different hierarchy, we can have different, more specific functions that go in, but then also some parts share functions, right? So then it makes it more reusable. So let's show how it works without, if we don't use super, and then we'll show how we use super, and we can look at the difference. So, so when we don't use super, then we can see that unlike above, when we use super, only child constructor is printed, which highlights the non-hierarchical like relationship that we have without using super. And then when we use super, it will print both of them. So then you can see here if we do this. And then now both of them are printed. So that highlights the importance of using super is basically a keyword when we want to use functions from the higher class. So next, let's talk about method overriding. So what's method overriding? Method overriding is exactly what it sounds like. It's just taking what we had thought we had in the like taking a method that we have in the parent class and writing it to do something else in the child class. So just a specific definition when and why do we use it? Um, we allow the child class to customize behavior while keeping the parent class structure and makes code more flexible and dynamic, which again we can use with the animal idea. For example, animals can also have an attack class function, but then within specific animals that inherit from the animal class, we might want the attack to do different things, but we still want an overall attack function. That way it's easier to be defined. So for example, And then now it shows that when we use the method overriding, it doesn't use the parent one, it'll use the child. So again, now we can actually, for example, code an animal example where let's show an example of not using inheritance and just write a completely separate cat and dog class. So that would be what this does is we take in a parameter when we define the class as a name, and then we just give the attribute of the class. The attribute of this dog class will be a name, and each instance will have a different attribute or name. And then this function basically does is we just print out that the animal is eating, the dog is eating. And then let's move on to our cat class. And then if we wanted to create different instance variables, we can do new dog equals and when we run it, we have woof woof comes from this, meow comes from here, dog.eat, buddy's eating, whisker, cat.eat, whiskers is eating. So then here we can notice the problems that come with not using inheritance, right? Or the more annoying parts, right? For example, for the eat function, they have they do the same thing, but we have to write it multiple times. Here in this case, when we only have two animals, that's not that bad. We only have to write it two times. But if you wanted to expand your program to include like 10 animals with like zebras, giraffes, hamsters, rats, like horses, then you wouldn't want to keep writing the eat function, right? So we need an overall upper class that is an animal class that is the eat class that has an eat function that will work universally work for all animals. And additionally, we also notice that they both have the make sound function, which is, although it's not exactly the same, this is something that could be used with method overriding, right? which we w went with above, where they have the same name of the function, but they'll do different things. So yes, problems with this code. Down. And another problem with this is that if you wanted to change the E method, you have to go through each different class and change it exactly the same, which would get quite annoying quite quickly. And it's also less organized, right? Because we keep defining the same function over and over again, and it gets repetitive. So the solution to this, of course, is using inheritance. We'll use a base animal class with common behaviors and subclasses like dog and cat that inherit and extend those behaviors. Um, Inherit, eat, override, make sound, for example. Okay, so to do this, we can do we have an animal class. And by the way, usually when we name classes, the common syntax is to always start with an uppercase, which is a little different than functions, which we usually use camel case on or underscores, but no matter what the function is, it's always going to start with a lowercase. But classes are different, they'll start with uppercase. So first, of course, we need the constructor. And then we do eat again, which is the same as before. Common behavior. We can add another common behavior like sleeping. And then now let's move on and add to our classes that inherit. So how do we write a class that inherits? So for example, class dog, we'll add the parentheses and then we put animal. And then we need the constructor again. But we don't even need the constructor. It'll automatically call the animal constructor. So then we just need the make sound function within dog. Then we can add the cat class that also inherits from animal. And then if you want to create instances again, same thing as before. Run this. We have the woof and meow, them eating, and them sleeping. And here we can see that this function, this type of inheritance, um, is much simpler, right? Because if we didn't use inheritance, we'd have to write the eat and the sleep for both classes, and it would get more annoying. So now can you guys write another animal class and give them their own unique sound function? So for example, you could add a mouse class or an alligator class and type it in the chat and use inheritance correctly. Okay, so basically how we could write another class is similar to before where we could do and that is just another class. So the benefits of inheritance, we have no repeated code. For example, eat is defined only once. Better organization. All animals being in the same category makes it easier to add another animal, like what we did with mouse. And easier maintenance. So when we add a new update, then we don't have to update every single animal. For example, with eat, if we want to update eat, we only have to do it once, which is much easier. So then we can also add, let's add more animal types. So for example, we can have, let's copy this part. And then let's define a bird class. And when they make sound, we can have we can also add other functions, for example, fly. And this is important part of inheritance where we can add different functions for different classes, but they don't apply to every other class that's inherited from the same one, right? When we have it. So it would be weird if we had like a fly function for dog or cat. So we can just define it specifically for birds. So make sure to be careful when you have a function in the higher classes like animal, that the more broad class, make sure that it's a kind of function that you would use in like all of the subclasses. And then we can also, for example, define a fish class. And a special characteristic that the fish could have is swim. And also have a reptile class. And special function, crawl. And if we want to call any of these, we can have, for example, dog equals dog buddy again. Whiskers, bird equals bird, Tweety. And when you make a new object, make sure you name the class exactly like it is. So bird is exactly capitalized. And we also have fish equals Nemo, reptile equals reptile. And for example, let's make them all do like sound. So dog, dot, make sound. And then we can also call the inherited methods again. So we do dog.eat. And then we can also do the special specific method like bird.fly, fish.swim, reptile.crawl. And now when we run this all, this is printed, right? These are all the sound methods. This is the inherited methods that every single animal could do, and these are the special ones. Okay, so benefits of this approach again is code reuse, extensibility, and specialization. Code reuse, we saw this before. Eat and sleep can be used multiple times. Extensibility, we can easily add more animals like we saw. It was much easier to add this. Imagine if we had to add the eat and sleep method for every single new animal. That would just be like a little bit too much. And then specialization, it's also beneficial inheritance because each class can still have their own behavior. So we're not sacrificing anything. It's only a win-win situation when we use inheritance. So make sure to use inheritance. So next, let's go over 3-level inheritance. Well, basically, that's just a class inheriting from a class that inherits from another class. So for example, we can have animal mammal, dog, slash cat. Why do we want to use this inheritance? Because yes, um, cats, dogs, birds, reptiles, they're all technically animals, but cats and dogs, for example, have more in common than, for example, cats and birds, right? Because cats and dogs both are mammals, they both like give birth live, they both like produce milk, unlike birds that like lay eggs and they have like feathers, unlike mammals who have fur. So sometimes we want to make further distinctions between classes, which is why we have another subclass because dogs and cats do have some more certain things in common, but they don't have in common with birds. So then we want another subclass that can have more methods. But then for this specific mammal class, it's only inherited for the mammals like dog and cat. So how do we use this? Again, class animal. Self-explanatory at this point, I hope. And then now we can have, let's add the mammal class. So class mammal. And then we are inheriting from animal. So like that. Then another constructor. And then we can add a specific thing to mammals that are like, for example, warm-blooded equals true. So this is what's handy about the animal class, like the mammal class. So for example, if you wanted to do a warm-blooded Boolean and then you were going to use it for every animal, it'd be very inconvenient to have to define that for every single different type of bird and every single different type of mammal, right? But if we have this mammal class, when we do this, this will be the case for every single new animal that we have. It'll automatically be set to warm-blooded equals true, which again makes the code more reusable and more organized. And then you can also have the give birth function. So yeah, this is something that's uncommon for mammals, but not for every single other species, which is why it's useful to have subclasses, right? Because then we can better have more organized code. So then, for example, if you wanted another subclass, we can have the reptile class, right? Because snakes, lizards, they're all reptiles and they have more in common than, for example, snakes and cats. So then we want to inherit from animals. We can, but here we'll set cold-blooded to be true, which is true for all reptiles, but not true for all animals, which is why we need this more specific class. that we can do. Here we have they're laying eggs, for example, and that's something that mammals don't do, which is why we want class, for example. And then now we can add more specific objects that inherit from these specific classes. So for example, we can have class dog, but instead of like before where we inherited from animal, we'll inherit from mammal. So we have this. And then we'll have the make sounds function. Now we can also fetch. And this is again useful because we are able to inherit all these classes from before, these objects, but then we have our own special dog functions. And inheritance doesn't need to just go to 3 levels. For example, it could be even more specific and go down to, for example, the different breeds of dogs like Dalmatians, like golden retrievers, poodles, and inherits. The beautiful thing about inheritance is we can do as much as we want and get as specific as we want, but also not sacrificing any of the code organization that we wanted. So then we can also have the cat class that inherits from mammal. Yeah, the climb well. Then we can also do classes that inherit from the reptile class, so for example, snake. Special snake one could function could be slither. We have a lizard class that's also a reptile. And this is so quiet, so then we can print dot dot dot. We can also do change color cell, the special function that lizards have. And then to call all these functions, again, we can create instances. So and then if we call these methods, And then if we print all of this, wait, what happened here? Um, we don't- always make sure to double check your code when you're typing. So here we can see this, for example, this method is inherited from the very super class animal, and then this is inherited from mammal. This is specific to the dog class. This is also specific to the dog class. You can have the cat climbing, that is specific just to the cat class. The snake can eat, which is again from the superclass animals. Lay eggs from the reptile class. Slither from its own class. Lizard can change color from its own class. So we can see the usefulness of inheriting multiple times because it'll save time, right? For example, if we didn't have the in-between layers of mammal and reptile, we'd have to add lay eggs for both of them, and that would also get quite annoying soon. So, yes, the breakdown of the inheritance structure is we can draw it out. We had an animal class as the top class, but then under it, we had um, the mammal and the reptile classes. And then under that, we had the for mammal we had dog and cat, and for reptile we had snake and lizard. So that's so this would be the animal class would be called the base, and it defined the two common characteristics that were eat, sleep. And then below that we had the mammal class that had a special characteristic of give birth. But in the mammal class, we can also call eat and sleep because these are inherited. And the reptile, we have lay eggs. And and the reptile, we also have eat and sleep. So that was our second layer. And then the level three, our specific animal classes, we had specific behaviors like dog had fetch, cat had climb, snake had slither, and lizard had change color. That shows how the hierarchy structure worked. And then why should we use these multiple second level classes? Well, get a better categorization, and we can again improve coding structure and avoid redundant code. For example, mammals don't lay eggs, reptiles don't give birth to young. So we couldn't add that in the animal structure. We couldn't add these to give birth and lay eggs in the animal function, but both dog and cat give birth. So it would be annoying to have it just specifically in dog and cat and rewriting it for every mammal. Same thing goes with lay eggs, which is why we should use these inheritance and these second level classes. Then it'll also add, for example, easier future expansion. So for example, when we did above, you could also add another second level class of birds and fish later on too. So when do we use inheritance? We use inheritance when there's common behaviors and you want to avoid code duplication and make updates easier, or you want to make the group similar objects under a common type. But don't use inheritance if you have subclasses that don't share enough common behaviors. So for example, we don't want cat and snake to inherit from something, right? Because they don't really have that much in common. It would be weird to give them an inheritance of the same thing. And then you could only need a few unrelated features, then you also shouldn't use inheritance. So in this class, we learned how we use inheritance in Python, and also not just how, but also why we use it and when to use it. So that's um, it for today's class, and thank you for coming.